Start off with NumPy in today's session. NumPy, as I mentioned before, that it gives us the ability to manage arrays effectively. Now, why do we need to manage arrays in Python? Especially, I'm talking about with the data science and machine learning context, where we have to deal with a lot of data and deal with and major part of your machine learning and data science projects are going to be dealing with data. 60 to 70% of your work in data science projects are going to be dealing with data, accepting data from different formats and managing them, massaging them, analyzing them, transforming them in various shapes and forms, so that your data science predictive analytics or your machine learning models can ingest them, or you can present your data, bring insights from your data and present your insights using visualization to your stakeholders. All right, so lion's share of your work in data science and machine learning will involve handling data. Now, this data represent a lot of different things. So in your business, if somebody is working for a bank or working for a bank financial services client, there are financial transactions. If somebody is working on HR application, there are people related transaction, payment information, monthly income, employee data, etc., etc. So there are business transaction data that are stored, and your data may be related to such business transaction. On the other hand, there are a lot of applications that involve data such as image data. Okay, image are stored in form of numerical arrays. Image are not stored as images. Images are stored in in numerical arrays. Textual data, when we work on various natural language processing application, we have to deal with textual data, and this textual data also are stored in terms of numerical arrays in your computer. Okay, so given that, management of arrays is very, very important. Our ability to create and manage arrays and manipulate arrays and analyze arrays, bisect, dissect and transform arrays is very, very important, and that is why we have a full library called NumPy, which gives us those capabilities. Okay. Now, one thing to understand is that NumPy provides an n-dimensional array storage, powerful set of array handling function, and strong support of mathematical operations on arrays using linear algebra, Fourier transformation, and random number capabilities. Okay, so it unlike series and data frames, which limit us our capabilities to handling one-dimensional and two-dimensional arrays, series being one-dimensional or data frame in pandas being two-dimensional, NumPy arrays can handle any dimensional in any dimension in terms of arrays shape. Okay, so that's one very big strong point of NumPy arrays. So to start with, you have to install NumPy. So depending on which environment you are working on, if you have Anaconda, you can easily issue the conda install NumPy from your Anaconda Jupyter notebook itself. Or if you have Brew as your installer, you can use Brew, or you can use the Python installer using pip install NumPy. So you have to make sure, normally if you are using Jupyter notebook, your NumPy library is going to be already installed, so you don't have to bother about it. But otherwise you may need to install NumPy if it is not installed in your environment. Post installing, you also have to import. So before you issue any NumPy command, any function, or try to create any NumPy array, you have to import NumPy as an alias, and normally by convention we use np as the NumPy alias. So once we have imported the NumPy library, we are all set to use it. So the first thing that we are going to try to do is we will create a simple array. So how do we create a simple array? We will use the array function from NumPy library and say pass a set of two list objects. So these are list objects. So if you have attended one of the previous session about Python introduction, or if you have done some research on Python language itself, you would have come across the list objects, which is a inbuilt data structure provided by Python itself. Okay, so array is not an inbuilt capability or inbuilt function or inbuilt data structure in Python. List is. So we create a list and we pass a list or a set of two lists to the array function. Okay, so this is the syntax, and as we pass the two lists, we get our array created. Now if you print the array, this is what you have provided and this is what you have received. So the two lists that you have provided are going to be individual rows in the array that is created. Okay, so you may be interested in understanding what is the shape of the array in terms of how many rows, how many columns that are there in the array. So you can use the shape attribute of NumPy arrays, and you will be shown the shape of the array, which is in this case 2 rows and 5 columns. All right, so each of your lists had 5 elements, and you have provided 2 rows, two set of 2 lists, and accordingly NumPy has created an array with 2 rows with the 2 lists and as many number of columns as there are elements. Now there are other mechanisms, many other different mechanisms of creating arrays. So one is the random function. So using the random function, you can and the random function is part of the random module, which is within the NumPy library again. So with the random function, we can create random numbers, an array filled with random numbers. So in this case, we are again passing the shape of the array, which is 3 by 3, and by using the random number, instead of passing definite numbers, we are filling the array positions with the random numbers generated by the random function. Okay, so this is another mechanism of creating arrays. Now there are a lot of different situations where you need to use random numbers. And essentially a lot of different times you need to test your models and test your predictive model or machine learning model, and you may need to generate some sample data, and in those cases the random function come in very, very handy. Okay, another mechanism of creating an array is using the arange function. Now what arange does is that it creates as many number of elements in a flat array, one dimensional array, as the number given to it as a parameter. So in this case I am passing the parameter 30 to arange function, and it is creating a sequential range of 30 numbers, okay, starting from 0. All right, now this is one dimensional, and sometimes this may not be that useful, and you may need to have the sequence for sure. However, you may need to have a multi-dimensional array. Okay, let's say we want to have a two-dimensional array of 5 rows and 6 columns. So in that case, it will reshape. So arange has created this, which is a flat array, one-dimensional array. Okay, and now we take that flat array and we issue the command reshape, which will convert the one-dimensional array into the dimension that you have provided. Now this is subject to that this comes to this many numbers. So there is a prerequisite. Okay, so in this case, this flattened array is converted into 5 rows and 6 columns as you want it. So that reshape function does the magic. The next example we can see is that you now have a function or an array which is this. Okay, so this is what we are doing, and doing it again. And in this example, you see, if you notice the command, we have issued 2 commands. One is the first instance we have issued the arange function, and the second instance which returned a flat array, and subsequently we have issued the reshape function on the array that arange has created, and that has reshaped it to a 5 by 6 array. Now there is another way of doing the same thing and within the same command. So instead of splitting this operation into two different commands, we do it in one command. So this expression returns the array, flat array, and this expression, so this actually means that, okay, take the return value of this expression, take it and apply the reshape function on top of that. Okay, that is exactly what it has done, and it is possible to stack function after the other in one statement instead of splitting out splitting out your operations in multiple statements. Okay, so this is a pretty convenient mechanism that Python provides. So when you print out this array, it prints this, which is your array which you have got previously, and then you want to flatten it, and NumPy provides you the flatten function. So you apply the flatten function on top of the array that you have received from here, which is a 5 by 6 array, and you flatten it and you will get this. So basically, again going by the same principle that, okay, we have an expression we have an array from this expression, which is this array, 5 by 6 dimensional array, and then you apply flatten onto it. So you can actually write it in the same statement, continue with this statement and write dot flatten, and you will actually get the same array that your arange 30 has returned. Okay, so flatten will actually nullify the effect of the reshape function. So you can try it on your own and see the effect. Some of the other cases that we have is that one important function about arrays or any data structure for that matter in any language is once you create them, the ability to access them. Okay, now array is a n-dimensional creature or n-dimensional data structure. We may need to access a single element, or we may need to access a slice of the array. Okay, it can be a contiguous number of rows, or it can be a contiguous number of columns, elements in a particular column, or it can also be a slice of contiguous rows and columns in combination. Okay, so everything is possible by means of mentioning the row subscripts and column subscript, or row indexes and column indexes, with starting value of the row, ending value of the row, followed by comma, and starting value of the column and colon, ending value of the column. So there's a simple syntax that Python offers for accessing array elements. Okay, so in this case, what we are trying to do is that we are trying to access a single element which is from the second row. So second row is indicated by the number 1 here, and third column. So third column is indicated by number 2. So when you say array name within square brackets, so indexes have to be enclosed within the square brackets, and the row number and the column number, so it accesses that single row. So this syntax is for accessing a single row. So it prints out 8, which is second row, third column, 1 2 3 third column. Okay, so this is for accessing single element from the array. Now you can, here in this case, we want to access elements on the second row, third to fifth positions. Okay, so what do we want to have is second row, which is this, from third to fifth position. So I want to get 8, 9 and 10, right? Second row, third to fifth position. So in the while printing also, it prints 8, 9 and 10. So we want 8, 9 and 10 from this array. So how do I mention that? I have to mention the row number. So in this case, the second row, so that is 1, followed by comma, followed by, and in this case I don't want a single element, I want a slice of this row. So I have to mention a starting position and I have to mention a ending position. So the starting position is 2, which is the third element in this row, and the ending position is 5, the fifth element in this row, right? And the row is 1, which I have already mentioned. Okay, so this is how you can take a slice from a particular array, particular row in a two-dimensional array, right? Now here in this case we want a column slice. Okay, on the third column, it says on the third column, third to fifth row positions. Okay, so what is my third column? So 0, 1, 2. So this is my third column. So if you can follow my cursor movement, so this is my third column. Positions third to fifth. So third position is this 14, 20, 26. So I need 14, 20 and 26. So how do I mention that? The first you have to mention the rows. So which rows are you looking for? You are looking for third, fourth, fifth rows. Okay, so starting position is 2, ending position is 5. So 2 colon 5 comma, which column you want? You want the third column, so 2. So this expression is going to give you 14, 20, 26. 14, 20, 26. Okay, so this is so this is how you can take a column slice. Now if you want to take a row slice versus column slice, row slice plus column slice, so basically you want to cut out an array from your original array, then you have to mention starting position, ending position of the row, as well as starting position, ending position of the column as well. So basically the same principle of indexing is applicable. So essentially you get 14, 15, 16. So 14, 15, 16 as so this box actually. All right. So and that is done by mentioning this 2 colon 5 comma 2 colon 5. If I have a data structure, okay, which is an iterable, we want to be able to iterate through that iterable. Okay, now how do we do that? We will have two examples. One is iterating through rows and one is iterating through columns. Now iterating through rows is pretty simple and straightforward. So what we have is again we create the same array of shape 5 by 6 with the values written by a range, so which is fine. We are comfortable with that right now. And what we are doing is we are using a for loop. For loop takes an iterable, so your array is the iterable in this case, and it is going to process one row at a time. So by default, if you apply a for loop on an array, on a two-dimensional array, it is going to return one row at a time. Okay, so each time it is going to print one row, and this is what you get. Okay, so iterating through columns is a little tricky. So what we do is we will issue this, we will access the shape attribute of the array. Now what does shape attribute return? The shape attribute returns the shape of the array, which is going to be, if you remember one of the previous example, we have seen an example of shape. So shape attribute returns a set, or rather a tuple, with your number of rows and number of columns. So that is a shape. If that is the case, then what is shape 1? Shape 1 is going to be 5. Shape 0 is going to be 2, which is the number of rows, and shape 1 is going to be the number of columns, which is shape 1. Okay, so that is stored in the calls variable. And if I take range calls, what does it do? It returns me a range which is starting from 0 till 5 numbers. Okay, because shape 1 has written 5 and calls as 5, so this is equivalent to range 5. So range 5 means 5. So basically, so I'm taking one number at a time and processing the numbers iteratively. Now the first time this for loop executes, the value of n is going to be 0. Now if I say this expression ARR1 colon, which is row number by default, starting row number, ending row number by default, and this n is equivalent to, this n is equivalent to 0, 1, 2, 3, 4, which is the column position here. Now when we do that, what we get as return is your columns here 0, 6, 12, 18, 14. So 0, 6, 12, 18, 14 here, 0, 1, 7, 13, 19, 25, 1, 7, 13, 19, 25. So this is actually flipping the operation here. Okay, now this is not exactly same as the row operation for arrays. It is actually is a little trick that you have applied. So range of columns, and you are accessing all the rows for each of the columns. So we take the first row, or rather, so we take the first column, which is signified or indicated by 0, which is 0 at the first time this for loop executes, and then we take all the rows, all the row values of the 0th column. So we get 0, 6, 12, 18, 24, and we are printing it. Of course we are printing it sidewise, so we get this, and it goes on as the number of the value of n changes. So it changes to from 0 to 4. Okay, so this again, this subscripting mechanism follows the same formula that you have applied here. Okay, so couple of tricks here. We have the Arcsort method of Numpy, which actually returns a sorted array of indexes for your array. Now what does it mean? Okay, so let's look at the example. So in our example, we have this arrays with values 70, 60, 50, 10, 90, 40, 80. All right, now what I want, and each of these have a subscript number, right? So the subscript numbers are for this 0, 1, 2, 3, 4, 5 and 6. All right, 7 elements. So these are the index number or subscript number, whatever you term it as. Now what I want is that a function which sorts this array. Okay, so I'm sorting it first. So Arcsort is first sorting this array. However, it is not returning me the sorted array, but it is returning me an array which is the index number in the order of these values in sorted manner. Okay, so when you return it, when you print it, the value that is returned by Arcsort on applied on score, it is going to return to me 3521. So 3 is 10 because there's a the smallest number, 3 and 5, 40 is the second smallest number, 2, then 60, oh sorry, 50, 1 which is 60, and so on. Okay, so this is not the sorted order of the array returned in sorted order, but the index values of the array in the order of the values being sorted. Okay, so this is a pretty interesting function here. Now there is a little nifty application that this example has created, which is I have a corresponding array. So this is one array and this is another array which has the same element, same number of elements. So this has 7 elements, so this also has 7 elements. So now I want to extract, so and this array's name is name. Okay, I want to extract the elements from this array in the order of these values in sorted manner. Okay, so what do I need to do that? Think about it. So that is why I'm saying it slowly. Think about it a little bit. My goal is to reorder these values in this name array in the order of this array in sorted manner. Okay, so this array in sorted manner we need the indexes in the sorted manner for this particular array, which is returned by Arcsort applied on score. Okay, so which is this one. Now what I'm doing is I'm using the name array and I'm applying that expression, which is this array. So what I'm saying is that I need these elements from this array and give me that order. Okay, so that is sorted name and I am getting this. Yeah, so this one is getting printed. So Danny, so Danny corresponds to 10, which is the smallest number. So Danny, and Fanny is this one, so this is the second largest number, etc. So we are basically extrapolating the order from here and applying the order onto this. Okay, so that is the trick. So pretty nifty example. Now you can also have the argmax function or the argmin function to find the index position of the max values or minimum values in an array. So basically, what you have done is in the previous example is used Arcsort on a complete list of arrays, complete list of values in an array, one dimensional array, and got the order through Arcsort. Argmax and argmin are pretty simple functions, which is going to return you the index value of the maximum number from your array. Okay, so we have this array. So this is a two-dimensional array with 6 elements. The shape of this array is 2 rows and 3 columns, and the np argmax x a is returning 4. Why is it returning 4? It is returning 4 because it has found the highest number, which is 14, in the 4th position. So 0, 1, 2, 3, 4. So it is counting sequentially. It has not given me the shape, but it is counting sequentially and has given me the position in the sequential, as if it is a considering it as a flat array. Okay, now the np argmax applied on the same array on the basis of columns, index of max element in each column, is going to return me this. Now let's try to interpret it a little bit. So we are looking at this now, and it is returning. So it is looking at 10 and 13, which is the first column, and returning 1 because it is between the two values in this first column. It has found the highest value in the second position. So this is returning 1. After that, it is looking at the second column. So I'm looking at all column wise. Okay, so then it is looking at second column, and it is saying that, checking that among the values 12 and 14, which are in second column, which one is the max value, which is the second position. It is returning 1. On the third column, it is looking at 11 and 10, and it is seeing that, okay, the 0th position or the first position has the max value in the third column, and it is returning 0, which is a first element. And same thing, if you want to do it on each row, it's going to return you this. Okay, so basically when you say this, it is going to look at row wise, and on this row it has found the highest value in the position number 1, which is the second position, and on the second row also it has found the highest value in position number 1, which is the second position, and it has returned 1 and 1. Okay, pretty cool applications of argmax. There is also another function called idx max, and another one called idx min. So that sends the index value of the maximum in a dimension of an array. So you can look up those idx max and idx min function. and know more about them. Now after array, we will go to the pandas library. Now pandas library is also very popular in terms of very commonly used in your data science and machine learning applications, and series object and data frame objects are given by supported by the pandas library. Now series is a multi-dimensional data structure, single dimensional data structure. It has one dimension of values. However, on top of the one dimension of values, series also has a index labels or labels. Okay, and those labels can be manipulated as well. So by default, when you have a series object created with some values, it has index numbers or index labels by default by as 0, 1, 2, 3, 4. But this 0, 1, 2, 3, 4 can be changed into any other label as you want. So if you want A, B, C, D in place of 0, 1, 2, 3, 4, that can be done, and we will see how we can do that. Okay, and the other object that is supported by the pandas library is the DataFrame object, and DataFrame object offers a wide array of functions and attributes for various types of manipulation in your data science and machine learning projects and other projects, other type of applications as well. Now data frame is a two-dimensional data structure. It's organized as rows and columns, and rows and columns both have index levels. By default, the indexes, the row indexes are by default 0, 1, 2, 3, 4, like I mentioned about the series object, and columns also have by default it can be 0, 1, 2, 3, 4, but normally for our common type of application, we will have meaningful name given to the column names to the data frame object. So one of the common ways we populate data frames is pulling in data from database tables or CSV files or flat files or Excel sheets, etc., directly into data frame objects. And by default, data frame can take the first row as or in case so first row of a Excel file or CSV file as the column header. Okay, so some of these capabilities are there, and data frame objects being two-dimensional data, it supports a lot of function which are like Microsoft Excel operations. So like, say for instance, you can create pivot tables using data frame objects. You have operations which are similar to RDBMS tables, like merging of multiple data frames, like we can do joins in RDBMS tables. The operations such as outer join, inner join, all those are possible using data frame objects. Okay, so we'll see some examples as to what magics can be done using this series and data frame. So first of all, we see how we can create a series object. So again, pretty simple, similar to how we have created the array object. We also have the pandas series object, and we pass a list of values as the values for the series object, and it creates this series. So by default, as I said, the index, so this first column here that is printed when you print this series object, this is the index values for each of the values for series, and these are the values. The second column are the ones that you have provided. So as I mentioned that you can also mention specific or custom index labels for your series objects. We have this option, index equals, while you are creating the series object, and you mention the custom labels or custom index labels as a list of values. Okay, so when you have the second series object created, it is looking like this. So instead of the default 0, 1, 2, 3, 4, you have A, B, C, D, etc., the ones that you have mentioned. Okay, so there is also another way of creating the series object, which is from the dictionary objects. Now, what are dictionary objects? If you remember If you have done Python language before and you have understood or gone through the internal data structures like sets and lists and tuples and dictionaries, these are the internal data structures of Python. So if you have gone through dictionaries, you would remember that dictionaries are actually key value pairs. Okay, lists, sets and tuples are lists of values or contiguous set of values. Now in case of a dictionary, it's a key value pair. It's a series of key value pairs. Now series also that I have mentioned have two things. One is your index labels and the values. Now you can equate that to the structure of a dictionary. So it makes sense that we have the capability of converting a dictionary object into a series. So and we can do it both ways. We can create a dictionary using a series object, and we can create a series using a dictionary object. So in this case, what we are doing is we are taking a simple dictionary object and passing that dictionary into the series function and creating a series object ser1. So when I print it, it prints this, and this is exactly what your dictionary was. So you had keys in the dictionary as A, B, C and D, and values 1, 2, 3 and 4, and that is exactly what this new series has. Okay, so that's a simple way of converting a dictionary object series object from a dictionary object. Now there is also another trick that you can apply. You have a dictionary object with, let's say, 100 elements or 100 pairs of key values, and you want specific key value pairs to be converted into your series object. You don't want all of those 100 key value pairs from the dictionary to come into your series object. You want specific ones. So in this example, the second example, what you are doing is, with the index parameter in the index argument, you are mentioning the keys that need to be pulled into the series object that you are creating. So you are mentioning the keys C and B, and when you print your ser1, you have C and B. So this is another way of filtering the keys from a dictionary when you are creating a series object from a dictionary. We go into the next example, and we see that how we can access series objects by specifying index values. So we have seen some examples from NumPy arrays, and it's no different. The principles are principles of accessing the objects are similar, and we will see how we can access individual elements from the series objects. Okay, so this is your series object. You have mentioned the values and you have mentioned the indexes, and we are mentioning with ser key B or index value B colon D. So this expression means that give me all the values from this series object from the key name or index name B till D. So it is starting from index name B and it is giving you till D. So it is actually extracting a slice from the series object, right? Also, the Pandas data frame and series objects have something called indexers. Indexers such as LOC, ILOC, and IAT and AT. So there are 4 or 5 indexers that are available in the series objects and data frame objects, and we will see some examples of them. So for instance, you want to extract value from your series object which has the index level of B, and you use the LOC or locate indexer with this index value, and you get this element, okay, 4. We can also do the same thing by mentioning a slice. Again, this is similar to mentioning the slice of starting index level and ending index level directly with the series object, but you can also do the same thing with the indexer. The second indexer is ILOC indexer, in which you have to mention the integer location, the numerical location. So in this case, what it is going to print is 8, because you are mentioning that you want to extract the third element in this series. Or on the other hand, the other way you can do it is mentioning the starting position and the ending position in the indexes. So that is 2 to 4th element, and it is going to extract this slice from the series object for you. One cool example with append is we have two series objects and I want to append one after the other. Okay, and you create your two series objects and issue the append function on the first series object and pass the second series object as parameter. So then the significance of these two are that this is your original series object, this is the first series object, and this one is going to be appended after this. Okay, if you flip the position, the reverse will happen. Now when it comes to copying a series object, and that is this is same in DataFrame objects also. Let's say you want to create a copy of your series object. Now the copy can be of different types. One is deep copy and one is a shallow copy. Now what is a shallow copy? Shallow copy is when you have a shallow copy, it actually is a different memory reference to the same physical memory location. Okay, it's not a physically separate copy that you are creating. Now both of them will need the copy function. In one case I'm mentioning deep equals to true, and in another case I'm mentioning deep equals to false. Okay, so when I'm saying deep equals to false, it is creating a shallow copy. So shallow copy, as I mentioned, is going to create a different memory reference or different name for your original series. So what you can do is test by changing one of the values in your original series object and check whether it has changed in the copy series. Okay, so in series 1, you are changing this element, okay, the third element, and you are printing ACR3, which is a copy of ACR1, a shallow copy of ACR1, and you see this, it is printing what is exactly should be the content of ACR1. Okay, because ACR3 is a shallow copy, basically a different name given to the same physical location where the series is stored. Now the deep copy is a physically separate copy. So if you do the same thing you do the same test, that you change an element in the original series object and you check the deep copy series object, you will see that it is not reflected. Okay, so that is the exact test that we are doing here. So deep copy creates a physically separate copy. Shallow copy with the deep equals to false parameter with copy will create a different memory reference with a different name for the same physical copy of the original series. Okay, so that's same for series, and that is exactly the same for DataFrame as well. Now in a lot of cases in your data, when you are working in real situations, you will find that your data contains the data that you receive for your data science and machine learning initiatives contain null values or missing values. Okay, and in Python, when you print them, they come up as NaN. Okay, now we create a series object and we forcefully change one of this series object elements as NaN. So it does not have a value, it's a missing value. And then what I want to do is that I want to drop this element from the series. Okay, and again this functions the same in DataFrame as well. In DataFrame, if you issue a dropna function, it drops the entire row where a missing value appears. Okay, in series, of course, it is a one-dimensional data structure, so it removes that element. So what I want to do, my goal is that delete or remove all the elements where there is a missing value from my series object. So this is my series object. The third element is having a missing value. I say drop now. So I mean, this is a blind command. So just be careful that drop now is a blind command. Okay, so you are not specifying which rows to target, you are just or which element to target. We are flatly saying whichever element has missing value, drop it. Okay, so you have to be very sure before issuing the drop now function, either on series object or on DataFrame object. Okay, so and you see the result, it has indeed deleted your missing element, okay, from the series object. So these are some of the cool examples from series object. There are this is only a very small subset. I mean, probably 5% of or 10% of the total capability of what series objects can do. There are a lot more to it. With that, we go into our last part, which is the DataFrame object. Okay, so what we do is, as I was mentioning before, is that we normally, one of the common practices is pulling data into DataFrame from a CSV file or a Excel sheet. Okay, so you have the read CSV function given by Pandas, which pulls in data directly from a CSV file. Okay, you also have another function called read Excel, so you can mention a Excel sheet and then pull in the data from the Excel sheet as well. Right, then what happens is your data is pulled like this, and as I mentioned before, the first row of the CSV file are taken in as the column header or column label in the data frame. Okay, all the remaining rows are data values in this case. So this particular so the read CSV creates a DataFrame object, and when we print this, it looks like this. So you have all kind of different values. You have missing values as well, you have float values, you have integer values, you have textual values, all of those kinds. Now what I want is, and I mentioned that there's a lot of capabilities that Microsoft Excel has, and RDBMS tables have those kind of capabilities. Some of those kind of interesting capabilities are available with the Pandas DataFrame object. Okay, now one of these capabilities, the ability to sort by particular field. So what I want to do is, I want to sort the rows in my data frame on the basis of the resale value. Okay, so this is car sales transaction, so I want to know which cars had the highest resale value. So I am sorting the data by resale value, and I'm saying ascending equals to false. So basically I want the highest number, the biggest numbers to come up at the top, and that is what it is doing. Where is it? This is the resale value, and it is indeed sorting on the basis of highest to lowest. Okay, so sorting is one interesting, a very commonly used function as well. By way of accessing the data frame elements, you have the same indexes that are available to series objects are also available to the data frame object. So ILOC indexer is available for cutting slices from the data frame. So you can, so we have seen in the case of multi-dimensional arrays that we can cut slices from the array. So we can take a column subscript, we can take a row subscript, and we can also take a row column combined slice. Okay, a multi-dimensional slice. So in this case, we are taking a two-dimensional slice from the data frame. So I'm saying that starting from second row to the third row, and starting from second column to the fourth column, give me the slice. Okay, so this is starting from the second row to the third row, and second column to the fourth column. This is the slice that it has cut, which is coming from here. Resale value, vehicle types, and price in thousands. Resale value, vehicle type, and price in thousands, and it has given me this slice. The other interesting ability, which is similar to Excel for with filter condition or RDBMS tables, we can use this kind of conditions with SQL commands. So with the data frame, what I want to do is that I want to have all the rows where engine size is this. So engine size is greater than 2. So we have engine sizes, all kind of engine sizes, so 1.8, 3.2, 1.8, 1.9, 2.4, etc., etc. And I want only those ones which have a value greater than 2 in engine size. And here it has filtered all the rows with engine size greater than 2. And by way of mentioning conditions, you can also have complex conditions. So this is a simple condition, so you can have a combination of multiple conditions in the same expression. So you can say and result value greater than so and so, and or sales in 1000 less than so and so, etc., etc. So you can create a combination of multiple conditions and create a complex filter condition. You can also create new columns, new derived columns in a data frame. So when you say csv_df, which is our data frame name, and a new column name, it actually sees that okay, this column is not existing, so I create this additional column in the data frame. And what do I put in that new column? I put in this derived value, which is the multiplication of result value column to 0.8. Now see this expression in a normal RDBMS table, or in a normal other kind of programming languages, let's say in Java or any other programming languages like C or C++, etc. You can't have a expression like this. Now this expression actually means that create a new column discounted value, and for all rows fill that new column with this expression, the corresponding result value from all rows multiplied by 0.8. Okay, so normally in other programming languages you have to perform this operation in a loop, in an iteration, starting from the first row to the final row. Okay, however here in this case it's a simple expression which is saying that okay, create this new column for all rows corresponding result value, multiply by 0.8 and fill in the new column. Okay, no iteration, nothing. Now we've mentioned before that you can have a lot of missing values in your data. I mean, when you are working with functional systems and you are pulling in data from your functional systems for purpose of data analysis, etc., you may have a lot of missing values. I mean, it's very realistic. Every organization you will find this kind of cases. In every situation, almost in every situation you will find these cases. There are various ways of dealing with those missing values. One of the ways of dealing with these missing values is Filner. Okay, fill the missing values with the specified value. So in this case what we are saying is that wherever, and this is again a blind command. So as I said that dropna, in case we've seen an example of dropna in case of series object, and here in this case we are seeing an example of Filner. This dropna and Filner are very dangerous commands. They are blind commands, and you are not sure what all it is updating. So wherever it is filling facing a missing value in any row, any column throughout the data set, it is going to fill it with 0. Okay, so with this blind commands, you have to be very sure what you are doing. You have to have a measure of how many rows are having null values, which columns have null values. If it is really appropriate to fill those null values with 0, or filling those null values with 0 will lead to some issue, and once you are sure, you can issue this blind commands. Okay, so what it does is that okay, so in our data set, the second row has a null value or missing value in price in thousands column. Yeah, so that third row after the Filner command is or Filner function is executed is filled with 0. Now I want to check the effect of Filner. So what I'm saying is I want to have all the rows from this data frame where there is a null value in this field, price in thousands. Okay, so and here in this case we are using the original data set. Okay, and I'm checking that I want all those rows where I have a null value or a missing value in price in thousands. So here are those rows. So there are two rows it is returning. which have null value in price in thousands. Then I'm checking, I have created this new data frame with Filner function. Okay, now I'm doing the same thing, but in this case with the filldf data frame, where this null values are filled with zeros. So I'm checking it again, doing the same thing, and it is not returning any rows. So that means the Filner has been successful. So both these rows are filled with the price in thousands column is filled with zeros. Now what we want to do is we want to create a pivot table. So we first explain the data. So we have created a data frame gm_df from an Excel sheet or a CSV file called gapminder.csv, and we have the country, year, population, continent, life expectancy, and GDP per capita. So Gapminder is basically a data. So Gapminder is basically an organization, a Swedish organization, which does a lot of research on socio-economic aspects and political aspects, and they publish a lot of data to the public, okay, for public's general people's awareness. The kind of data which are normally may not be available, or normally may not be available in consolidated aggregated formats. So it publishes a lot of data. So here is one such data example where Gapminder has given data for population, life expectancy, and GDP per capita for a lot of countries, I think all countries in the world, for the years 1952 till 2007, with a gap of 5 years each time. Okay, so that's a data, that's a Gapminder data. It's commonly known as and it's popularly used in a lot of data analysis examples. So what we want to do is that we want to create a pivot table like this. Okay, so let's look at the output first. We want a pivot table like this, where by continent we will list down all the countries, and we will list down the average GDP per capita for all the rows for those countries. Now what does it mean? That means, so this part is fairly explanatory, I guess. Per continent, per country in that particular continent, I want the GDP values, but the GDP values should be the average GDP values for that particular country. I'm saying average GDP value for that country because in this data set there are about 11 or 12 rows per country, which is the number of rows between 1952 and 2007 with gaps of 5 years. Okay, so as all the countries have multiple rows, and in all of those multiple rows you have a value against the GDP per capita, etc. You have to our goal is to take the average value of those years per country, and that is exactly what we have done. Now what is the expression? We have the pivot table function that is applied on the data frame, the Gapminder data frame that we have created here. So this is the Gapminder data frame, and what I'm saying is that index the pivot table by first by continent, within continent by country. So first by continent here in the first column, after that by country. Okay, and in the values I need GDP per capita, which is coming from this last column, and the aggregation function that you need to apply on GDP per capita is mean. Okay, so that is the meaning of or interpretation of this expression, and this is it is creating this pivot table. Just like you can create a pivot table in Excel very easily, is the same ability on data frames. So with this we have come to an end of all the examples that we wanted to show to you about NumPy arrays, Pandas series, and DataFrame objects. So thank you again for attending this session, and we will see you in the next session. Thank you.